In the summer of 1944, American Seabees accomplished what German engineering experts had declared impossible. Using only basic equipment, a handful of bulldozers, and sheer determination, they transformed jungle-covered coral into a fully operational airfield in just 5 days, a task German engineers had estimated would require 5 months of intensive labor. This wasn't just construction, it was America's secret weapon in the Pacific Campaign, the ability to create infrastructure faster than the enemy could comprehend. The 14th of June, 1944, Shimada Island, South Pacific. 0530 hours. Lieutenant Commander James Harrington wiped sweat from his brow as the tropical sun began to rise over the dense jungle. The humidity was already suffocating, but that was the least of his worries. 2 days ago, his battalion of Naval Construction Battalion, the legendary Seabees, had landed on this strategic island with an impossible mission: build an operational airstrip for Marine Corsair fighters in less than a week. The usual timeline for such a project was measured in months, not days. Every engineering manual, every construction expert back in Washington had said the same thing. Coral bases require extensive preparation, proper drainage systems, specialized equipment. The captured German assessment had been particularly dismissive. Their engineers estimated 5 months minimum for a proper runway on this terrain. But the Marines needed that airstrip now. Japanese reinforcements were expected within the week, and without air support, the American foothold on this critical island could be lost. So here he was, with 200 Seabees and a handful of bulldozers, attempting the impossible. Lieutenant Jack Morrison approached, his uniform already soaked with sweat despite the early hour. "Sir, the survey team has marked the clearing line. We're ready to start the bulldozers whenever you give the word." Harrington nodded, studying the crude map they'd drawn up the previous evening. "About those coral formations on the north end?" "That's where it gets tricky," Morrison admitted. "According to the German engineering assessment we captured, those coral beds would require specialized drilling equipment and at least 3 weeks to properly clear. We don't have that equipment, and we certainly don't have 3 weeks. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you." Harrington almost laughed. After everything they'd been through from Guadalcanal to Tarawa, some German engineer's assessment wasn't going to stop them. He raised his binoculars, scanning the dense jungle that needed to be transformed. What he saw next would shape the course of the Pacific Campaign. "Start the bulldozers at 0600, he ordered, "and get me Chief Petty Officer Sullivan. I think I have an idea about those coral formations." The first bulldozer roared to life at precisely 0600, its mighty blade tearing into the jungle underbrush. Then another and another. Within minutes, 6 Caterpillar D7 bulldozers were advancing like a mechanized army, transforming the landscape with raw American power. Senior Chief William Sullivan, a former construction foreman from Pittsburgh, watched with undisguised pride as his men attacked the impossible task. At 42, he was older than most of the Seabees, with deep lines etched around his eyes from years of squinting in the sun on construction sites across America. "What do you think, Chief?" Harrington asked, shouting to be heard over the roar of engines. "German assessment says those coral formations need specialized equipment. 3 weeks minimum." Sullivan spat on the ground, his expression somewhere between amusement and contempt. "With all due respect to our German friends, sir, they overthink everything. Those Krauts would design a special coral cutting machine, spend a month testing it, then write a 100-page manual before they ever moved a pebble." "And your solution?" Harrington prompted. "We've got 4 cases of dynamite, 6 bulldozers, and 200 men who aren't afraid of hard work," Sullivan replied with a grin. "By sundown tomorrow, that coral will be crushed and ready for grading." This was the Seabee way: no specialized equipment, no years of development, just American ingenuity and brute force practicality. Regular men with construction backgrounds turned into military builders who could transform a hostile jungle into a functional airbase faster than anyone thought possible. Commander Richard Hayes, the battalion's engineering officer, reviewed their makeshift plans with growing concern. He had been a civil engineer for 7 years before the war, trained at MIT, and what Sullivan was proposing violated everything he knew about airfield construction. "This is madness," he told Harrington privately. "Blasting the coral and then immediately grading without proper settling time? The runway will develop sinkholes within weeks. The drainage will be completely inadequate. German engineers estimate 5 months for a reason. It's simply not possible to compress that timeline this drastically." But Harrington had seen the Seabees work miracles before. Those German assessments assume European methods, European equipment, and European timelines. "We're Americans, Hayes. We don't have the luxury of doing things by the book. Not here, not now." By noon of the first day, the Seabees had cleared a 300-yard swath through the jungle, exposing the coral bed beneath. The men worked in shifts under the punishing tropical sun, stripped to the waist, their bodies glistening with sweat. Water consumption was carefully monitored to prevent dehydration, but no one complained. Every man understood what was at stake. Captain Marcus Reynolds, the Marine liaison officer assigned to coordinate with the Seabees, watched in astonishment. He had fought alongside the construction battalions before, but never had he seen such concentrated effort against such daunting odds. "I've seen the German assessment," Reynolds told Harrington as they observed the progress. 5 months, they said. Specialized equipment, a team of 50 engineers. Harrington merely smiled. "They don't understand Americans, Captain, especially Seabees." By 1600 hours, Sullivan's demolition team had prepared the first series of controlled explosions. The charges were set with practiced precision, designed not to simply blow the coral apart, but to fragment it in a way that would create usable foundation material. "Fire in the hole." The warning cry echoed across the clearing as everyone took cover. The series of explosions sent coral fragments flying skyward, leaving a cloud of dust that momentarily blocked out the sun. When it cleared, the seemingly impenetrable coral bed had been transformed into workable rubble. Within minutes, the bulldozers were back at work, pushing the fragmented coral into position, beginning the crucial grading process that would turn rubble into runway. The sounds of construction, the rumble of heavy equipment, the shouted orders, the rhythmic pounding of hammers created a symphony of American industrial might in the middle of the Pacific jungle. Private First Class, Michael Donovan, just 19 years old and 6 months removed from his father's construction business in Chicago, operated his bulldozer with skill that belied his youth. When his machine suddenly sputtered and died, he was out of the cab in seconds, tools in hand. "What's wrong with it?" asked Lieutenant Morrison, hurrying over. "Fuel lines clogged with debris," Donovan replied, already working to fix the problem. "Give me 5 minutes." Morrison checked his watch. "We don't have 5 minutes, son. Use Kowalski's machine." Donovan shook his head stubbornly. "With respect, sir, Kowalski's already pulling double duty on the south end. I'll have this fixed in 3 minutes, not 5. His hands moved with practiced efficiency, stripping, cleaning, and reassembling the fuel line faster than any manual would have prescribed. True to his word, the bulldozer roared back to life in just under 3 minutes. Morrison couldn't help but smile. This was why the Seabees were different. Every man was both soldier and skilled tradesman, capable of adapting and improvising in ways that conventional military units and certainly conventional engineering assessments could never anticipate. As night fell, work continued under hastily erected floodlights powered by rumbling generators. The standard procedure would have been to cease operations at dusk, but standard procedures had no place in this operation. Time was the enemy as much as the Japanese, and neither would wait for daylight. Chief Sullivan organized the men into 3 rotating shifts, ensuring the work would continue around the clock. Sleep was a luxury few could afford more than 4 hours of, but complaints were non-existent. The impossible task had become a point of pride. They would succeed precisely because everyone had said they would fail. By dawn of the second day, nearly 40% of the runway was roughly graded. The progress was remarkable, but Hayes remained concerned. "The compaction isn't sufficient," he warned Harrington. The German assessment specifically mentioned the need for specialized vibratory compactors for this type of coral base. We're using bulldozers to do a compactor's job. Sullivan overheard the conversation and interjected. With respect, sir, we modified the bulldozer tracks last night, added weight and altered the pattern. They're compacting better than any specialized machine because we're making more passes. German engineers would never think of that, using one machine to do multiple jobs. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Story. Hayes remained skeptical but couldn't argue with the results. The modified bulldozers were indeed achieving compression rates that, while not textbook perfect, were serviceable. It was another example of Seabee ingenuity, transforming standard equipment into specialized tools through simple, practical modifications. By midday on the second day, word of the Seabees' progress had spread throughout the island. Marine units began to gather during their off-duty hours to watch the impossible take shape. The runway was now clearly defined, stretching over 2,000 feet, with work progressing on the final 1,000 feet required for Corsair operations. Private James Wilson, a former road construction worker from Texas, supervised a team laying the crucial final surface. In textbooks and German engineering manuals, this process required specialized machinery, carefully mixed materials, and precise temperature controls. Wilson had none of these. We're mixing the coral with crushed volcanic rock from the island's north side, he explained to Captain Reynolds, who had come to check on their progress. Adding seawater in controlled amounts creates a chemical reaction in the coral that actually helps it set harder. No German engineer would approve, but it works. Reynolds watched in fascination as the improvised surfacing material was spread and compacted. How long will it last? He asked. Wilson shrugged. Long enough, maybe a month before it needs significant repairs. But we'll be here to make those repairs, and a month is all the Marines need to establish control of the island chain. This was the fundamental difference between the Seabee approach and the German engineering mindset. German designs prioritized permanence and perfection runways that would last for years without significant maintenance. The Seabees built for the immediate strategic need, understanding that in war, good enough right now often trumped perfect later. As the third day dawned, Harrington allowed himself a moment of cautious optimism. They were ahead of schedule, with nearly 70% of the runway operational. If they maintained this pace, they might actually complete the impossible task with time to spare. Then disaster struck. At 0930 hours, a torrential tropical rainstorm descended without warning. Within minutes, the worksite was transformed into a muddy quagmire. Water pooled in the partially completed drainage ditches, and portions of the newly laid surface began to wash away. Hayes didn't bother to hide his concern. This is exactly why the German assessment called for a 5-month timeline, he said grimly. They accounted for weather delays and proper drainage construction. We've been cutting corners, and now nature is extracting its price. For the first time, Harrington felt a flicker of doubt. Had they been too ambitious? Too dismissive of conventional wisdom? The rain showed no signs of abating, and every minute of delay brought the Japanese reinforcements closer. Standing in the downpour, mud up to his ankles, he gathered the shift supervisors. Gentlemen, the Germans didn't account for American stubbornness in their calculations, he shouted over the drumming rain. Divide your men, half continue runway work under tarps, half divert to emergency drainage channels. Within 30 minutes, an entirely new drainage system began to take shape. It wasn't in any manual, didn't follow any established engineering principle, but it addressed the immediate problem with brutal efficiency. Hand-dug channels, reinforced with scrap material and sandbags, directed water away from the crucial runway surface. By afternoon, as the rain finally slackened, the improvised solution had saved the project. Water damage was minimal, and work on the runway itself had continued, albeit at a reduced pace. They had lost precious hours but had demonstrated something the German assessment couldn't quantify: adaptability in the face of unexpected challenges. The fourth day brought new problems. The heavy equipment, running continuously for over 72 hours, began to break down. Bulldozer engines overheated in the tropical climate. Hydraulic systems failed under the strain of operating far beyond their design parameters. A conventional military unit would have been paralyzed. The German assessment had specifically cited equipment limitations as a major factor in their 5-month timeline, assuming regular maintenance schedules and replacement parts. The Seabees had different ideas. Chief Machinist's mate Robert Johnson established a field repair shop that worked miracles with limited parts and tools. Engines were rebuilt using components cannibalized from less essential equipment. Hydraulic lines were spliced and reinforced. When conventional repairs weren't possible, unconventional solutions were invented on the spot. The Germans think in terms of replacement, Johnson told Harrington as he supervised the rebuilding of a bulldozer transmission using parts from 3 different vehicles. We think in terms of adaptation. They'd wait a month for the correct part. We make the incorrect part work today. By sunset on the 4th day, despite equipment failures, weather delays, and the inherent challenges of the coral terrain, the runway was 90% complete. The impossible was now within reach. That night, as the work continued under floodlights, Harrington received word from Marine headquarters. Japanese ships had been spotted just 200 miles away. Air support would be needed within 48 hours if the American position was to be maintained. Harrington gathered his officers. "Gentlemen, we no longer have the luxury of our original 5-day timeline. The runway must be operational by 1200 hours tomorrow." Hayes began to protest, citing the remaining work, the technical requirements for a safe landing surface, the German assessment that had already been proven correct in so many ways. Sullivan silenced him with a raised hand. "Commander Hayes, with all due respect, those German engineers were building for the Luftwaffe. We're building for American pilots. There's a difference." The final push began immediately. Every available man was called to duty, regardless of previous shifts. Sleep was forgotten. Food was consumed on the move. The distinction between officers and enlisted men dissolved as everyone, regardless of rank, contributed to the monumental effort. By dawn of the 5th day, the runway was taking its final shape. The surface was rougher than specifications called for, the drainage more rudimentary than any engineering manual would approve, and the overall design simplified to the point that German engineers would have considered it dangerously inadequate. But it would work. The Seabees knew it would work because they had built it with American pragmatism, not European perfectionism. At 1,100 hours, 1 hour ahead of the revised deadline, Chief Sullivan approached Harrington with a simple announcement. "Runways ready for inspection, sir." Harrington walked the length of the makeshift airfield, marveling at what his men had accomplished. In less than 5 days, they had done what German engineering experts had declared would take 5 months. It wasn't pretty, it wouldn't win any design awards, but it would allow Corsair fighters to land and take off, and that was all that mattered. At precisely 1,145 hours, the distinctive drone of Corsair engines could be heard approaching from the east. The first squadron of Marine fighters, desperately needed for the island's defense, was arriving to test the Seabees' miracle. Men stopped working, all eyes turning skyward as the first Corsair lined up for its approach. This was the moment of truth. All their effort, all their ingenuity, all their defiance of conventional engineering wisdom, it all came down to this moment. The first Corsair touched down at 1,147 hours, its wheels making firm contact with the runway. The Germans had said couldn't possibly exist yet. The fighter rolled to a stop, and for a brief moment there was total silence. Then a cheer erupted from 200 Seabee throats. They had done it. They had accomplished the impossible. They had compressed 5 months of careful German engineering into 5 days of American determination. By sunset, 12 Corsairs were parked on the newly constructed airfield. Marine pilots approached the Seabees with a mixture of gratitude and disbelief. "We heard about this runway," one pilot told Sullivan. "Headquarters said it couldn't be done in the time frame. The captured German assessment said it would take 5 months minimum." Sullivan smiled wearily, his face etched with exhaustion but glowing with pride. Germans don't understand Americans, son, especially Seabees. We can do, that's our motto, and we mean it. The impact was immediate and strategic. Japanese forces, expecting to find an island defended only by ground troops, encountered fierce air resistance when they arrived 2 days later. The battle that followed was decisively shaped by the presence of the Corsairs, which wouldn't have been possible without the runway that couldn't exist. In Washington, the report of the Seabees' achievement was met with astonishment and immediate classification. The ability to construct military infrastructure at speeds the enemy couldn't anticipate became a strategic advantage too valuable to publicize. The strategic implications of the Seabees' achievement extended far beyond that single island. Lieutenant Colonel Victor Kramer, a Marine intelligence officer, compiled a classified report on the psychological impact of rapid American construction capabilities. The Japanese High Command has been thrown into disarray by our ability to establish operational airfields in a matter of days rather than months, Kramer wrote. Their entire Pacific strategy was predicated on the assumption that island fortifications could be established faster than we could build the infrastructure needed to support offensive operations. The Seabees have shattered that assumption. Intercepted Japanese communications revealed growing alarm among enemy commanders, where conventional military wisdom, including the captured German engineering assessments, indicated that American forces would need months to establish air bases on captured islands. The Seabees were doing it in days. This compressed timeline disrupted Japanese defensive planning at a fundamental level. Major Takeshi Yamamoto, a Japanese engineering officer captured in late 1944, expressed this dismay during interrogation. We believed we understood American capabilities. We studied German engineering estimates. We planned accordingly. But your naval construction battalions operate outside all conventional parameters. It is not warfare as we understand it. The story of Shimada Island might have remained classified indefinitely if not for a journalist named Michael Thornton. Embedded with Marine units in the Pacific, Thornton witnessed the Seabees' miracle firsthand and understood its significance beyond the immediate tactical victory. What I saw on Shimada Island wasn't just construction, Thornton would later write in a Pulitzer Prize-winning article. It was America's industrial spirit translated into military advantage. Those Seabees didn't just build a runway, they built a new concept of what's possible in modern warfare. Back in the United States, the Seabees' achievement prompted serious reconsideration of construction timelines and capabilities. Admiral Benjamin Morton, who had initially been skeptical of Harrington's compressed schedule, became the Seabees' most vocal advocate in Washington. The German engineering assessments we've been using as benchmarks are fundamentally flawed, Morton told the Naval Construction Committee. They assume European methods, European timelines, and European perspectives. Our Seabees have demonstrated repeatedly that American ingenuity, combined with our industrial capacity, operates on an entirely different scale. The Seabees themselves were often unaware of their strategic impact. They saw their work as practical necessity rather than revolutionary achievement. Chief Sullivan, when interviewed for a classified naval report, expressed surprise that anyone found their methods remarkable. Most of us were construction workers before we were sailors, Sullivan explained. On a civilian job, if the boss says it needs to be done in 5 days instead of 5 months, you figure out a way to make it happen or you find another job. We just brought that attitude to the war. This disconnect between self-perception and reality became apparent when Harrington's unit rotated back to Pearl Harbor for reassignment. They were stunned to be greeted by Admiral Chester Nimitz himself, who personally commended them for rewriting the rules of military engineering. Harrington's men looked at each other in confusion. In their minds, they hadn't rewritten any rules. They'd simply done what needed to be done, using the skills they'd brought from civilian life and adapting them to military requirements. We didn't know we were doing anything special, Private Donovan wrote to his parents. The officers told us we needed a runway in 5 days, so we built one. They said the Germans thought it would take 5 months, but what do Germans know about American construction workers? This casual dismissal of the impossible became characteristic of the Seabees throughout the Pacific campaign. Engineers trained in European traditions might insist something couldn't be done, but the Seabees would simply do it anyway, often using methods that horrified conventional military minds. Commander Hayes, the MIT-trained engineer who had been so skeptical of their methods on Shimada Island, underwent a profound professional transformation. In a paper submitted to the Naval Engineering Journal, promptly classified, he attempted to articulate what he had witnessed. The German engineering approach, which I was trained to emulate, emphasizes precision, standardization, and methodical progress, Hayes wrote. The Seabee approach might charitably be called improvisational and less charitably chaotic. Yet, in battlefield conditions, this chaos proves more adaptable than precision. They achieve in days what our manuals say should take months, not because they're ignoring physical constraints, but because they're approaching those constraints from an entirely different perspective. This shift in perspective had implications beyond military construction. As the war progressed, American commanders increasingly rejected European doctrinal limitations in favor of pragmatic American approaches. If the Seabees could compress 5 months into 5 days, what other impossible tasks might be accomplished through similar methods? The psychological impact on Japanese forces became increasingly apparent. Intercepted communications revealed that Japanese commanders had developed an almost superstitious fear of the Seabees. Where American Marines might land today, functional airfields would appear tomorrow, an acceleration of warfare that their strategic doctrine couldn't accommodate. Captain Hiroshi Tanaka, a Japanese staff officer captured near the Philippines, expressed this fear directly. Your Marines, we could fight. Your carriers, we could evade. But your Seabees, they changed the nature of time itself. Islands we thought secure for weeks became American air bases in days. The Seabees on Shimada Island, meanwhile, had already moved on to their next impossible task. With the airfield operational and supporting marine air operations, they turned their attention to constructing port facilities on the island's eastern shore, another project that German assessments indicated would require months. I give them 10 days, maximum, Admiral Morton predicted when, reviewing Harrington's plans. He wasn't disappointed. The port was receiving supply ships 8 days later. This compression of construction timelines had cascading effects throughout the Pacific campaign. Japanese defensive strategies, based on conventional engineering timelines, consistently failed to anticipate the speed of American infrastructure development. Islands thought to be temporarily vulnerable became permanently lost as the Seabees transformed them into fortified American bases faster than counterattacks could be organized. The impact on Japanese morale was devastating. Lieutenant Kenji Watanabe, a Japanese naval officer, recorded in his diary a sentiment that would become increasingly common among enemy forces. The Americans don't fight according to normal rules. Their construction units perform miracles. We capture their engineering manuals and prepare accordingly, only to discover the Americans themselves ignore these manuals. How can we fight an enemy who doesn't follow even their own doctrine? This question resonated through Japanese high command. Their military training, like Germany's, emphasized careful planning and methodical execution. Against an adversary who improvised constantly and succeeded despite violating established engineering principles, traditional military doctrine proved inadequate. The Seabees, for their part, continued to approach each impossible task with the same practical attitude. When informed that German engineers had declared a particular mountain pass on Luzon Island unconstructable within a 3-month timeframe, Chief Petty Officer Frank Delgado of the 113th Naval Construction Battalion reportedly replied, "We'll have trucks moving through it by next weekend." They did. By early 1945, the strategic advantage provided by the Seabees' construction capabilities had become so significant that their deployment schedules were classified at the same level as fleet movements. Japanese intelligence services prioritized identifying which islands would receive Seabee units, understanding that these locations would transform from jungle to operational bases with astonishing speed. Admiral Yamamoto himself reportedly told his staff, "The Americans have 2 secret weapons in this war, their industrial capacity and their construction battalions. The first gives them material advantage. The second gives them the ability to deploy that advantage faster than we can respond." The runway on Shimada Island, meanwhile, had already entered Naval Construction Battalion lore. New Seabee recruits in training were told the story slightly embellished, with each retelling as an example of what was expected from them. The Germans said 5 months, our boys did it in 5 days, became an unofficial motto, challenging each new group of Seabees to match or exceed the accomplishments of their predecessors. The captured German engineering assessment that had declared the Shimada runway a 5-month project was eventually displayed at the Seabee Museum in Port Hueneme, California, alongside photographs of the completed runway taken just 5 days after construction began. The exhibit became one of the museum's most popular, a tangible representation of American pragmatism triumphing over European doctrine. Dr. Klaus Hoffmann, a former German military engineer who emigrated to the United States after the war, visited the exhibit in 1958. After studying the photographs and documentation for several hours, he asked to speak with the museum curator. "This exhibit is missing something important," Hoffmann told her. "It doesn't explain why we were wrong." When asked to elaborate, Hoffmann provided an insight that would later be incorporated into the exhibit. German engineering tradition values perfection above all else. We designed for permanence, for optimal functionality under all conditions. We couldn't conceive of accepting the imperfections in that runway because our engineering culture forbade such compromise. The American Seabees understood something we didn't, that an imperfect runway now is infinitely more valuable than a perfect runway too late. This philosophical difference extended beyond military applications. In the post-war industrial boom, American manufacturing and construction continued to emphasize speed and adaptability over European-style precision. Companies that had contributed engineers to the Seabees brought back lessons learned in the Pacific, implementing what became known as Seabee scheduling, aggressively compressed timelines that conventional wisdom declared impossible. Sullivan, promoted to senior chief by war's end, found himself recruited by construction firms eager to apply military efficiency to civilian projects. During the interstate highway construction boom of the 1950 seconds, his methods developed under fire on Pacific islands helped compress building schedules across America. When asked about the German 5-month assessment for the Shimada runway, Sullivan would always shake his head with the same bemused smile. "Those Germans overthink everything," he'd say. "Always have, always will. That's why we won the war, and that's why we're building America faster than anyone thought possible." Lieutenant Commander Harrington, who had led the Shimada Island miracle, took a different lesson from their achievement. After retiring from the Navy, he established an engineering program at a Midwestern university that emphasized adaptability and improvisation alongside traditional technical knowledge. "The Germans weren't wrong about the physical requirements of that runway," he would tell his students. "Their calculations regarding materials, compaction rates, and drainage were technically sound. Where they failed was in imagining alternative approaches to those same physical challenges. They saw one path to the goal, the documented, proven path. The Seabees saw dozens of paths and chose the fastest, even if it wasn't in any manual." This willingness to depart from established procedure became a defining characteristic of American engineering in the post-war era. Projects that European consultants declared would require years were routinely completed in months by American firms applying lessons learned from the Seabees. The story of Shimada Island faded from public consciousness as the war receded into history. The runway itself, built for immediate tactical necessity rather than long-term use, was eventually reclaimed by the jungle. By 1960, little evidence remained of the miraculous construction that had altered the course of the Pacific War. But for the men who had built it, the legacy lived on. At a Seabee reunion in 1965, Donovan, no longer the 19-year-old bulldozer operator but a successful construction company owner, raised a toast that captured the essence of their achievement. To the Germans who said it would take 5 months, and to the Americans who did it in 5 days. May we always believe in impossible timelines. The laughter and applause that followed spoke to a shared understanding among these former Seabees. They hadn't simply built a runway faster than German engineers thought possible. They had demonstrated an approach to challenges that transcended military applications. In 1970, When NASA was struggling with compressed timelines for the Apollo program, a former Seabee named Robert Mitchell found himself in a meeting with German rocket engineers who had come to America after the war. The discussion turned to schedule feasibility, with the German engineers insisting that certain processes could not be accelerated beyond established parameters. Mitchell listened patiently, then asked a simple question. "Have any of you heard of Shimada Island?" The blank looks that greeted him prompted Mitchell to tell the story of the 5-day runway. When he finished, one of the German engineers shook his head in disbelief. "That is a military folk tale," the engineer insisted. "Physically impossible." Mitchell smiled. "I was there," he said quietly. "I operated a bulldozer for 72 hours with only catnaps in between. We did in 5 days what you're saying would take 5 months, because we had to. Now we have to put a man on the moon on an accelerated timeline. Which do you think is more important?" The Apollo program would go on to achieve its seemingly impossible timeline, drawing on the same American capacity for improvisation and acceleration that the Seabees had demonstrated on Shimada Island. In the decades that followed, as American and European engineering traditions increasingly cross-pollinated, the stark differences that had existed during the war gradually diminished. German engineering became more accepting of improvisation. American methods incorporated more systematic approaches. But in the annals of military history, the achievement of Harrington's Seabees on Shimada Island remains a testament to a uniquely American approach to challenges. Pragmatic, improvisational, and unconstrained by conventional wisdom. The final word on their achievement may belong to Admiral Nimitz, who wrote in his private journal after visiting the Miracle Runway, "When this war is won, it will not be won only by our superior numbers or industrial might, but by the spirit of men like these Seabees, who simply refuse to accept that something cannot be done." The Seabees didn't just build a runway in 5 days that German engineers said would take 5 months. They built a new understanding of what determined the boundaries between possible and impossible, not physical limitations or technical constraints, but the willingness to imagine and attempt what conventional wisdom declared could not be done. In 1995, at the 50th anniversary commemoration of the war's end, one of the last surviving members of Harrington's unit was asked to explain how they had accomplished their miracle on Shimada Island. "We didn't know it was supposed to be impossible," he said with a shrug. "So, we just did it." In that simple statement lay the essence of the Seabee spirit, and perhaps the secret of American success in the war and beyond. Not superior knowledge or technical skill, but the simple, powerful belief that the impossible was always worth attempting. The legacy of Shimada Island extends beyond military history. It stands as a testament to what can be accomplished when human determination confronts seemingly immovable obstacles. The Germans said 5 months, based on sound engineering principles and extensive experience. The Seabees said 5 days, based on nothing more than the urgent needs of war and their refusal to accept conventional limitations. And in that contest between established wisdom and American audacity, audacity prevailed. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.